Hi guys, today we're going to do 8-1. This is graphing linear equations. We have a couple definitions here. First one is what a linear equation is. And it's an equation whose solutions fall on a line. And that line is going to be a straight line because it is linear. The second definition is a rate of change. And that is a ratio that compares the amount of change in a dependent variable to the amount of change in an independent variable. And so if we move right on here to our example, the example says we're going to graph the equation and tell whether it's linear. So here's our equation. Now there are multiple ways of doing this. One way that you can do it obviously is using a graphing calculator. Now if you don't have access to that, then we're going to have to do it another method. And one of the ways that we can do it is we can write a chart, an XY chart, pick some values for X, and then find what the value of Y is, and then plot those points. Another way we could do it is we could use our slope-intercept form, the y equals mx plus b. The way that I'm going to do right here is I'm going to do an xy chart. So in an xy chart, basically, you are going to pick some values for x. So an easy one to start off with is 0. If you take 0 and you plug 0 into the equation, you'd have 3 times 0 minus 4, and that would just equal negative 4. So that would give you your value for y. Once you have that, come over to your chart or your graph, and we're going to plot that. So on the x, the horizontal here, you're not going to go anywhere, but on the y, we're going to go down to negative 4. So 1, 2, 3, 4. We're going to put a dot there. Then we're going to come over, we're going to pick another point. 1 is always a good one to choose, so if you take 1 and you plug it in there, that's going to be 3 minus 4. 3 minus 4 gives you negative 1. So then you have 1, negative 1. So if you come over here, you're going to go over to 1, you're going to go down 1. Let's pick another point, let's say 2. So that means you're going to put 2 in here. 3 times 2 is 6. 6 minus 4 is positive 2. So you'd have 2, 2. So go over 2, 1, 2, and up 2. Right there. Now you can choose as many points as you want. If you want to keep going, if you want to pick 3 and put 3 in there and see what happens, you can do that. So 3 and 3 is 9. 9 minus 4 is 5. Come over here and go 1, 2, 3. Go up 5. 1, 2, 3, 4, 5. Now you can tell here that my graph is not exactly perfect, like the spaces between my marks here aren't perfect, but that's okay for our purpose here. And I'm probably not going to draw the straightest of line, but you can tell that that's a straight line. So as you have your chart over there, you have your points, you're just going to connect your dots, make a line as straight as you can, and there's our problem. Y equals 3x minus 4. That's the line, there it is, graphed. So that's the process that you're going to go through to figure out how to graph it. Here's another problem, same directions. It's going to ask you to graph it, and going to make another XY chart. I'm going to pick some other values, so I'm going to pick 0. If I put 0 in here, that's negative 0 squared. Anything with a 0 in it, just going to be 0, so that one's going to be 0, 0. Put in a 1, so you can have negative 1 squared. 1 squared is 1. With the negative, that would give you negative 1. So let me go ahead and plot those 2 points. So 0, 0 is right there. 1, negative 1 is right there. Go ahead and do 2. So 2 squared is 4, and then you have a negative, so that would be negative 4. So go over 2, 1, 2, over 2, 1, 2, and then down 4, 1, 2, 3, 4. Now this doesn't look like it's a straight line right now, it kind of looks like it's curved. And here's the other thing that you should recognize, that you have a squared term. Anytime that you have a squared term, you can automatically tell that it's not going to be a linear equation, it's not going to be a straight line, because look what happens here if I do some negative numbers. So let's say that I put in a negative 1. If I put in negative 1, and I square it. Negative 1 squared would be positive 1, but then I have a negative there, so that's going to be negative 1. So if I come over here, negative 1, then I'm going to have to go down. Let's go ahead and do a negative 2 here. Negative 2 squared is 4, but then you have a negative, so that would also be negative 4, which that's going to be mimicking this side over here. So what you end up with is not a linear equation. You actually end up with a parabola, an upside down one, and you can see obviously that this is not a straight line. So when you're doing these problems and you notice that there's a squared term in it, you know that you're going to have some kind of shape very similar to this, and you know that it's not going to be a straight line. It's not going to be a linear equation. So if the problems, when you're doing your homework, if it asks, is this a linear equation, your answer is going to be no, and this is your proof of it, but you can also just tell because there's a squared term in it. So here's another type of problem that you're going to run across, and in this one, the directions say determine whether the rate of change are constant or variable. Now, a constant rate of change is pretty easy to tell. The variable one, maybe not as easy to tell right off the bat. One way that you can do it, now you can tell that this is an XY chart. You could plot these points. It'd be very easy to make a little XY and then plot these points, 0, 0, 1, 4, and then if it came out to a straight line, then you would know that it would be constant. If not, then it would be variable. So one way that you can do this is you can determine what the difference is between that. So you're going from 0 to 1, that's 1. You're going from 1 to 3, that's 2. You're going from 3 to 6, you're going up by 3. You're going from 6 to 8, going up by 2. Do the same thing with your y values here. So 0 to 4, 4. 4 to 8, 4. 8 to 8, 0. And 8 to 6, you're actually going down -2. So when you're looking at this, there's not constant things that are happening. There's not like a specific pattern, a concrete pattern. So if that's the case, then this is going to be variable. So if we give you another example here, when you're looking at these, you can tell that this is going up 1 from 0 to 1. This is going up 3. This is going up 2. And this is going up 1. Go down here on your y values, check and see what's happening there. So this is going up 1. This is going up 3. This is going up 2. And this is going up 1. Now you'll notice the difference between this problem and this problem. These are all the same. These are all different. So this one is going to be a constant. So that's how you tell the difference between the two. And like I said, you could graph this and look at it on a graph, but just do this with your charts. Find the difference between all of these. If these are the same, it's going to be constant. If they're different, it's going to be variable.